We're going to talk now about the E1 reaction. In the E1 reaction, the elimination or the one is the reaction that competes with the SN1 reaction. This reaction, what they have in common is that they happen stepwise, and they have that same intermediate. So they have, say, here, common intermediate. And that is a carbocation of some sort. We're going to see. That's, say, the general, and that's trigonoplanar. So that is, again, this reaction, because it happens with the formation of a carbocation, is also stepwise. So, stepwise. So what that means is that in the step 1, you have the formation of the carbocation. And in step 2, we're going to have a proton transfer. Here, because this is the rate determining step, the formation of that intermediate. So the, say, rate low, then only depends on the concentration of the substrate. So this is similar to SN1 reaction, so say identical. And you cannot distinguish, say, just by this rate low, if you have an SN1 or an E1. So profile-wise, it will be, again, 2 steps. This is your carbocation intermediate reactants products, so reaction coordinate, that's energy. And now, but the second step is different. So here we have then, first step is a carbocation formation, so from reactants to that intermediate. Second step is a proton transfer reaction. Now I'm going to be using the the same example that I used before to do the, let me get in what I like here. Yeah, that draws fine. We'll do contrast, is not that good. Okay, I'm going to change my marker here. All right, so say that I have same substrate. I'm using the same example that I've used before for SN1 and SN2. So again, I'm creating here a chiral center with a specific configuration. And we said that this process is stepwise, and the first step is then the formation of a carbocation. And that's my carbocation here. But now, what happens in the second step? Remember that this is common to the 2 reactions, and the 2 reactions happen under, say, polar product conditions. But this reaction needs, with weak base, it will happen with a weak base. So typically, we can have water, ethanol, those are very weak bases. Those are examples of that. Okay. Now, the fate of the carbocation then, if we have a nucleophilic attack over here, you will have a substitution, an SN1 product with a racemic mix if you started with something that was chiral. Now, when we're drawing the E products, the elimination products, we need to identify what are the beta hydrogens. So here in the initial molecule, that's my alpha carbon. So the next position is beta. This is also beta position. Here you have 1 hydrogen, and here you have 3 hydrogens, beta hydrogens. So I'm going to draw 1 hydrogen here, and I'm going to have now 3 over here. Notice this is not a beta hydrogen. It's here attached to the alpha carbon. These are the one that I just marked. It's going to say HB, one of these. I'm going to use one of these to eliminate. And so what happens, let's label that hydrogen type A, hydrogen type B to give you the products. So now say that we have a base, we can have water acting as a base, and in the second step, as we said here, proton transfer. Base will attack here, get the proton. You use the pair of electrons to make a double bond here. So the product would be the following: double bond here, and then you will have, that's a metal group, and that is a hydrogen, which I'm not drawing. See, I am omitting this hydrogen on the side. Here is a metal. So that's one product. Another thing that I want to say is that the alkene picture here is tri-substituted. Notice that at this carbon we have two metal groups, and here one. Here you have a hydrogen, so you have three. So the alkene here is tri-substituted. And let's do what will happen if I now use a base, and this time I'm going to use a different color. Let's say that now, instead of extracting hydrogen B, I extract hydrogen A. Same thing, so remember again, after the formation of the carbocation, the second step is your proton transfer. So base, come in, get the proton, and now you form a double bond here. So now let's draw the product. Here you will have now a double bond. I'm not drawing the hydrogens, and here you will have that. So what is different here? The alkene, in this case, has at the double bond, notice that this was this carbon, you have two hydrogens, so there is no substitution by an alkyl group. And here you have a hydrogen, this one that I didn't draw, and the isopropyl. So this, the alkene here is mono substituted. And so one substituting here, one of the hydrogens replaced by an alkyl group. And alkenes, the more ramified they are, so say tetra substituted are more stable than tri, and those more stable than di substituted, and that more stable than mono. And always the E1 reaction will give you as a major product the more substituted. In this case, between this one that is tri-substituted and this one, the major product then is the alkene here. The more substituted. That's always the case in E1 reaction.